Alright, so right now we're going to take an improper integral. The directions would say determine whether this improper integral converges or diverges, and if it converges, find what it converges to. I didn't bother to write those directions because students never bother to read those directions, but that's what we'll do. So we'll start by figuring out if infinity is the only place where this integral is improper, because if the function is undefined between 1 and infinity, we'd have to remove that point as well. But we'll check to see what the domain is. And the only place where the function could be undefined is when the denominator equals 0. So we'll set that denominator equal to 0. I'll go super fast through this without even saying anything. And we get that the denominator is 0 when v is equal to plus or minus 1 over 6. But neither one of those is in our interval from 1 to infinity. So we're defined there, so the only place we have to worry is at infinity. So we'll set this integral up and we'll write that it's equal to the limit as a goes to infinity of the integral from 1 to a. And now we have a proper integral. A is finite. It's arbitrarily large and it's getting bigger as we speak, but it's finite. And so this is an integral that we know how to deal with. So we'll just do some u sub. We'll let u equal to what's under the cubed root, and then du is the derivative of that. So we're going to keep that limit the whole time, but now we'll replace what's under the cubed root with u, and then we're also going to replace dv with what it equals in terms of du. And you can see those v's are going to cancel. Now we do need to be concerned about the bounds as well, because our bounds are no longer the same, because now we're integrating with respect to u, not v. And so we're going to go from what u equals when v equals 1 to what u equals when v equals a. So be careful that you don't write the old bounds here. And now when we plug 1 and a in, we get our new bounds. The v's will cancel, so here we go. But now we can integrate this. This is a straightforward integral. Don't drop the limit, because we haven't taken the limit yet. But here is our integral. Now we can plug in the bounds. Again, we haven't taken the limit yet. Continue writing that limit. But when we send a to sorry, this might have skipped, but as we send a to infinity, we see that that first term tends to positive infinity. So the whole thing is going to tend to positive infinity. So that means that the integral diverges, and we're done.